Welcome to DSA with Rashmi. Think, pattern match, and solve. Today we are solving the two-sum problem. Most people solve two-sum by brute force, but interviewers would want you to think in these following steps. Step 1. Don't hesitate to ask your interviewer cross questions in order to understand the questions clearly. Second step would be to list out the properties of the questions and decide which data structure would the question fit in. Third step would be to write an algorithm. Now let's dive into step 1. Understand the question thoroughly. So let's read the question. Given an array of integers num and an integer target. We have num and target over here. We have to return indices, that is the not the value itself but the indices 0, 1, 2, 3. These are the indices. We have to return indices of the two numbers such that they add up to the target. We have to find two numbers from this array which adds up to this target and return those indices as I told you. Let's read further. You may assume that each input would have exactly one solution and you may not use the same element twice. Okay, so this is an important thing to remember. You can return the answer in any order, no problem. Okay, let's go ahead and look at the examples. So first example, we have nums 2, 7, 11 and 15, and the target is 9. The expected output is 0, 1, 0, 1, comma 1. So what I would do is write the indices here so it becomes easier for me to think. Now we're just trying to understand the question. So what could we do is, if I add 2 and 7 over here, 7, 8, 9, 2 plus 7, which is 9, I'm getting the target. So probably I will have to return these two. Since they are telling that you have to return the indices, I have to return it. The moment I find those two indices, I can return it. So possibly there could be more matches in the array further, but what they're asking in the question is the moment I find the value, I return it. So let's go. So probably I'll be iterating over the array and see 2 plus 7, 9 works. Then I'll have to return 0, 1. I will now take another example, which is 3, 2, 4. The target here that I have to make is 6. Expected output is 1, 2. So what can I do? I'll see first two numbers. 3 plus 2, which is 5, is not the same as target, so I'll not use this. I drop it. Next two values, 2 plus 4, 6. It is matching the target, so this is my output. That is 1, 2. I'll see another example, the third example that they've given. 3, 3, the target that I have to make here is 6. I'm going to add, first of all, 0, 1 are these are the indices. And now I add 3 plus 3, which is 6. It is matching, so I'm going to return 0, 1. Anyhow, the expected output here was 0 and 1. Let's now move to the next step. Whenever we see things like, like two numbers in the question, or you have to find pairs, or sum equals target, like in this question. When you see these things, when you see these things, the for the most probable things that must come to your mind is check if you could use a hash map, or maybe think in the lines of two pointer approach, or see if the array is sorted. Okay, let's try to understand the question more. If we use a hash map, if we put all the values in a hash, if you decide to create a hash map, then it might look like this. The lookup certain value in a map happens in big O of one time complexity. That is, it gives you the value instantly. If you have to do a lookup in an array, it's going to take a big O of n time complexity, which is obviously larger than looking up in a map. So we could use hash map, but coming to two pointer, do we really need a two pointer? Actually, no, we don't need a two pointer. But the problem is, if we have to use a two pointer, our array need to be sorted. We don't have to use a two pointer. Most of the times, two pointer works best if the array is sorted. But the problem here is we cannot sort the array. If we sort the array, then the indices of the value might shift. We don't want that. So we're gonna drop the idea of two pointer and array sorted. Now what have we established here? Whenever there is a pair problem or a target sum problem, or we need a fast lookup, we will go with hash map. Now let's move to the third step, that is writing an algorithm. We need to do a pre-processing. That is, we need to create a map, which we have done over here. So what can I possibly do is, according to my algorithm, I need to have an empty map ready, declare an empty map, iterate over the entire array, and fill the map. Next step would be, again, iterate over the array. Iterate. Now the third step would be to, we have to iterate over the array again. For each value, think about it, for each value, if we subtract it from the target, the target here that we have to make is, target is 9. Now let's imagine, now we are iterating over this array. We take each value, we subtract it from the target. 9 minus 2, which is 7. Then we check, do we have 7 in the map? Yes, we do have 7. What we have to return? We just have to return this value and this index. That is all, I guess, we have to do here. Now what I'm going to do is, I will again iterate over the array to find each and every value. Now for every value over here, I'm going to calculate, I will just call it complement. Complement will be target minus, let's call this array ARR, array of I. Alright. Now we can imagine the complement over here is going to be like 9 minus 2, which is 7. Now I'm going to check if my map over here contains 7. Check if map has complement. If yes, I'm just going to return. I just have to return map of complement and I, basically the index. I will be the index of the array here, 0, 1, 2, 3. I will be the index. And map of complement is this. Map of 7 will give me 1. So it will be 0, comma 1. Or I must say 0, 1. Basically 1, 0. According to the question over here, we were told you can return the answer in any order. So it doesn't really matter 1, comma 0 or 0, comma 1. This can be the output. Now, there's one important thing that we've missed is that if you come back to the question and see, you may assume that each input would have exactly one solution and you may not use the same element twice. There cannot be any repetitions. Let me explain you by giving you by taking another example. That it's let's assume the nums is 7, 2, 12 and 16. The target that I want to make is 14. So now according to the algorithm, I'll first iterate over the map and then my map, I'll create a new map which is going to look like 7, 2, 12, 16. This is our map. After creating the map, we have to iterate over the array and find the complement. So I'll probably have a for loop over here which iterates from 0 to n. And then let's assume this is our first iteration, right? Like first iteration, obviously. So we are calculating the complement, which is target is 14 minus array of I, which is this 7, which is going to give us 7. Now, according to our algorithm over here, we have to check if map has complement. As soon as I find the complement in my map, I'm going to return. If I happen to do that, right? So, this is my complement. Does my map has my complement? Yes, it is yes. So I just have to return a map of complement, which is this 0, comma I, which is here 0. This cannot happen. This is what they're telling. There should be indices must not repeat. This is wrong. So when that happens, I have to continue with my loop over here. So I'll tell you another condition which has to be put here. That is, along with this, along with the existing condition, we have to check and if map of complement must not be equal to I. So if we put this condition over here, now it's not going to stop. It's not going to because over here this is also 0. This is also 0. It's not going to stop and return over there. But the execution is going to continue to the next loop I equal to 1. Now let's just convert this algorithm to the code. So according to our algorithm, we just need an empty map. We need to declare an empty map first, and then we'll iterate over the array and fill the map. Let's just do these steps. Let map equals new map console.log. I'm just going to console.log at every step. I'm usually used to doing this so that I can see where I'm going and what I'm doing. I have my map ready. Now I will iterate over the map. I equal to 0, I less than nums.length, I plus plus. Map in the map I'm going to add the nums of I, that will be each value of it. Nums of I equal to I, the index. Now let's console.log and check my map. Okay, has to be like this. My bad. Okay, my map is ready. Moving on to the next step, I want to iterate over the array and find the complement. So I'll have another for loop, nums.length I plus plus. Let complement equal to target minus array of I. Target minus array. Sorry, not array. I'm just used to array. Nums of I. Now that we found our complement, we need to have a condition, that is, check if map has complement and map of complement is not the same as I. If map of complement, that will alone check if my map has the complement value, and map of complement will give me its value is not the same as I. Only then I'm going to return map of complement and I. I will have to wrap this up in an array simply because that's how it's expecting the output to be. See? Alright. This code should technically work. Let's just run and see. It's working. Let's submit. Oh, working. Now let's talk about the time complexity and space complexity over here. Over here it takes the time complexity which is taking is big O of n because it's a for loop. We have another for loop over here. This also takes another time complexity of big O of n. So overall time complexity is big O of n. Now since we are using a map over here, the space complexity must also be big O of n.